Okay, in the last video, we looked at some standard code and we really emphasized the fact that when we pass values to a function, they really are different. They get a copy of our value, but they are not the same. If we change them in the function itself, they will not change in the function that's called that function. So let's look at a different case, how we can actually allow a function to make changes to variables. And it's going to require us to understand a little bit about pointers or addresses. So here's our stack. By the way, this time I've introduced the stack pointer so you can actually see it move. But if we create the first location, val1 main, it's going to have this value in it. Stack pointer is going to move up. We create the next one. We're going to put a value in it. Stack pointer is going to move up again. We create the next one. Put the value there. Stack pointer goes up. And now here's where it might get a little bit interesting. When we reach this point, of course, we know we have to store the return address. Where are we going to come back to when we're done calling this function? Because again, we could call it several different points in our program. So on the stack, we're going to go ahead and put that return address from foo, where we need to come back to. And then we're going to jump to the function. And the function it looks a little different. Notice these stars. This says we're going to use a very special kind of data here. It's going to be the address, not the actual value. So this is very much like your house and the address to your house. Your house is great big. If I wanted to store your house, I'd have to have a whole bunch of memory. But let's say I don't want to store your whole house. I want to just know where it is. And so I can change it later. I might just store your address. So instead of storing your whole house every time and making copies of your whole house, I'm just going to point to it using an address. So here's how that's going to work. We're going to create two new variables, myval1 foo and myval2 foo. But instead of taking copies of our val1 and val2 down here, I'm actually going to store in these locations the actual addresses of these memory locations. Know how this myval1 points to val1 and myval2 points to val2. All right. Now let's take the next step. Notice when I say, hey, instead of just saying myval1 equals 3, I'm saying find out where myval1 is and change the actual house to 3. So the star says change the house, not the address, but the house to the value of 3. And know how we're going to go find out where that value is and change its value. Same thing's going to happen here. We're going to find the address of val2. We're going to go to that location and change it. Now, what I want to do is not add two addresses. I want to add the actual values. So that's why I still use the star. So now I'm going to add whatever's in the address of my val1, which is, of course, val1, and whatever's in the address of my val2. And we're going to add those two together and return them. So that allows us then to make changes to values that are declared and managed by another function. Now, when I pop back, of course, all of these variables, all of this space is given back to the system. Now, we don't clean it out. If I were able to look at this, I'd actually see the old values. But if I tried to access any of these variables, the system's going to say, sorry, I don't know where those variables are. It makes no sense. Notice how our stack pointer is now still pointing to the top or the next location of our stack. All right. Now I want to have a little conversation about a very specific kind of variable. It can also be used, it turns out, to allow all functions access to variables. And they're called global variables. Now, in introducing this topic, I want you to understand that in most situations, global variables are actively discouraged. So in many programming environments, they're going to ask you not to use global variables because they're easy to misuse and they can cause defects. However, in embedded systems, we kind of use them pretty extensively, but mostly to access hardware that's at very specific addresses. But let's talk briefly about what a global variable is. So here's my code. Notice outside of any function up here, I have declared a value, a global value, and it is equal to 5. All right. When I do that, that global value is available to all functions, and I don't have to declare it in the function. So notice I have a function here that changes that value. I don't have to declare it here. Because it's a global variable, it's just available, already declared, to all functions. Down here, I can call my change value, change it to 10, and call my change value and change it to 15. Notice I don't have to declare it, it's just simply available. So the first time it's going to be 5 because that's what I initialized it to. The next time, because I've called this, it's going to be a 10. The next time, because I've changed it, it's going to be a 15. Now, again, it makes it very easy, but it's also quite easy to cause defects because there's no control over who has access to this variable. So we could be changing it in code we don't even know about and expect it not to be changed. So that's one of the reasons why they're actively discouraged. However, in our space, oftentimes we'll declare variables like this because they're associated with very specific addresses in hardware. Now, where are global variables stored? Well, there's kind of a special place for globals. So it's not the stack, it's not the heap, it's kind of a special place where they're set aside in data memory. All right. Now, hopefully that's it's a brief but fairly complete look at what variables are available to us and how they're stored in memory.